That's what part B, we found out the velocity of A when it reaches the bottom.
Yeah.
So that's what we're using here, and we're using that here as well. Okay? So then, if we want to know this, what do? Collision, which means what? Yeah, collision means momentum. Collision means momentum. And how do you start every single momentum problem? PI equals PF. Now, what's moving before? Before the collision? Yeah, just ball A, MAVA. What's moving after the collision? Both. MAVA final plus MBVB final. Of course, I can do what right away? Cancel all the masses, because in this case, the balls are the same mass. And so I get VB final equals VA minus VF, or whatever, VAF. Not exactly high-level calculus or anything. And that gives me 2.45 meters per second. Ding, done. We move on to the second part. It's an inelastic collision. How do I start again? PI equals PF. I hope you have noticed a theme. Okay. So then we say, once again, MAVA, and then we say MAV plus MBV. Does everybody understand why I put V? It's the same velocity, right? And that's what we're looking for. So I can say MAVA equals MA plus MB times V. Does that make sense? And since they're all the same mass, if I cancel it out, please be careful. If I cancel this out, what does this become? It becomes 1 plus 1. Okay? Please be careful about that. So then what I get is V is equal to VA over 2. And that becomes 1.3 meters per second. Now, the second half of this problem says change equal the kinetic energy final minus the kinetic energy initial. So, what was moving in the beginning? Only A. So I do 1/2 MA VA squared minus what's moving at the end? Both. So I take 1/2, and then here I can do MA plus MB, and then V squared. See what we're doing there? Yeah, it's just 1/2 MB squared twice. Okay, and now I got to plug in all that stuff. So this is, I don't know, whatever it is, 1/2 times 0.185 times 2.6 squared minus 1/2 times 0.370 times 1.3 squared. Okay, and what do you get when you do that? Okay, I'll do it myself. So I get 0.5 times 0.185 times 2.6 squared minus 0.5 times 0.37 times 1.3 squared. I get 0.313 joules of energy. That's the difference. Yeah. So again, please note this error here. I flip-flop these. So in the yellow, I've corrected it. The kinetic energy total minus, and when I say total, I mean of the total mass, the combined mass, minus the kinetic energy of ball A by itself. That gives us a negative 3.13 joules, which makes sense because we should have lost energy, which we did.